Imagine a giant eye, floating silently in the cold expanse of space, its gaze fixed on the distant universe. This is the James Webb Space Telescope, or JWST. Its primary mirror, a stunning array of 18 gold-coated beryllium hexagons, spans over 6.5 meters. It is the largest telescope ever sent into space. Its mission is monumental. It seeks to peer back to the dawn of cosmic time, to witness the birth of the very first stars and galaxies. It embodies humanity's unending quest to understand where we came from. JWST aims to study every significant phase in the history of our universe, from the faint residual glow of the Big Bang to the light from the stars that first illuminated the cosmos. It will investigate how galaxies assemble and evolve over billions of years. It will watch stars being born within dusty stellar nurseries. It will explore planets both within our solar system and those orbiting other stars. And, perhaps most profoundly, it will search for the conditions and chemical signatures that could indicate the presence of life beyond Earth. Building such an observatory was a colossal undertaking. Thousands of scientists, engineers, and technicians from across the globe poured their expertise into its creation. JWST is poised to open a new chapter in our ongoing cosmic narrative, revealing wonders previously hidden from our sight. Imagine you are trying to see a distant streetlight on a very foggy night. The fog scatters the visible light, making the streetlight dim or even invisible. The early universe was filled with vast clouds of neutral gas and dust. These cosmic clouds act like a thick fog, obscuring the light from the first stars and galaxies. Similarly, stars and planets are born within dense, dusty cocoons. Visible light, the kind our eyes detect, struggles to penetrate these veils. To see what lies within, or what lies beyond, we need a special kind of vision. We need to look beyond the rainbow. That special vision comes from infrared light. Infrared radiation has longer wavelengths than visible light. These longer waves are less prone to scattering by small dust particles. They can travel through dense clouds of gas and dust much more easily. Infrared light, therefore, allows us to peer into regions of space that are opaque to visible light. It unveils the hidden universe. JWST is an infrared specialist. Its large mirror collects as many precious infrared photons as possible. This makes JWST the most sensitive infrared observatory ever constructed by humankind. December 25, 2021. An Ariane 5 rocket launched from Kourou, French Guiana. Its cargo was the James Webb Space Telescope, folded origami style. The world watched with bated breath. A successful launch was the first critical step. JWST traveled to the second Lagrange point, or L2. At L2, gravitational forces keep the telescope stable. This location allows JWST's sun shield to block light and heat. Its massive sun shield unfurled. Then, the golden mirror segments opened and locked. The successful commissioning at L2 marked the beginning of JWST's mission. Light, the cosmic messenger, travels at an astonishing speed. In the vacuum of space, it zips along at approximately 300,000 kilometers per second. Yet the universe is so colossally vast that even light takes a considerable amount of time to traverse cosmic distances. The light from our sun takes about 8 minutes to reach Earth. Light from the nearest star system, Alpha Centauri, takes over 4 years. This finite speed of light has a profound consequence. Looking out into space is also looking back in time. When we observe a galaxy that is 1 billion light-years away, we are seeing it as it appeared 1 billion years ago. JWST is specifically designed to detect light from the most distant objects ever observed. This means it can see light that has traveled for over 13.5 billion years. JWST functions as a powerful cosmic time machine. For more than 3 decades, the Hubble Space Telescope has been humanity's most famous eye on the sky. It has delivered breathtaking images of celestial wonders, from colorful nebulae where stars are born to distant galaxies spiraling in the dark. Hubble has revolutionized nearly every area of astronomical research. It has helped determine the age of the universe and the rate of its expansion. It has provided evidence for supermassive black holes at the centers of galaxies. Its discoveries have become iconic, inspiring millions and profoundly shaping our view of the cosmos. JWST is often described as Hubble's successor. While this is true in spirit, it's important to understand that JWST is not simply a replacement. It is a different kind of observatory designed to answer new questions that Hubble couldn't address. Hubble primarily observes the universe in visible and ultraviolet light, with some limited near-infrared capabilities. JWST, on the other hand, is optimized for infrared light. They are complementary instruments. each providing a unique window onto the cosmos. JWST's primary mirror has a diameter of 6.5 meters, compared to Hubble's 2.4-meter mirror. This much larger collecting area means JWST can gather over 6 times more light than Hubble. JWST builds upon the incredible legacy of Hubble, pushing the frontiers of human knowledge even further into the vast unknown. One of the most profound questions humanity has ever asked is, are we alone in the universe? For millennia, this question was confined to the realms of philosophy and fiction. But today, thanks to telescopes like JWST, we are beginning to search for scientific answers. JWST is a formidable tool in the hunt for planets orbiting stars beyond our sun. These distant worlds are known as exoplanets. Thousands have already been discovered, but JWST is taking their study to an entirely new level of detail and sophistication. JWST doesn't just help find exoplanets, its real power lies in its ability to characterize them, especially their atmospheres. One technique it uses is called transit spectroscopy. When an exoplanet passes in front of its host star, a tiny fraction of the starlight filters through the planet's atmosphere. JWST's highly sensitive instruments can capture this filtered starlight and spread it into a spectrum. By analyzing this spectrum, scientists can identify the chemical composition of the exoplanet's atmosphere. They look for the telltale signatures of gases like water vapor, methane, carbon dioxide, and oxygen potential biosignatures. Early results from JWST's exoplanet studies are already incredibly exciting and promising. Each new observation provides unprecedented insights into the diversity of planets that exist in our galaxy. What wonders await us with the James Webb Space Telescope? Its mission is designed to span many years. We aim to find and study the first galaxies, understand star and planet formation, and characterize exoplanets. The most transformative discoveries are often the ones we least expect. The universe is full of surprises, and JWST is equipped to uncover them. Whenever humanity has built a more powerful instrument, we have stumbled upon new phenomena. JWST, with its unparalleled sensitivity and infrared vision, is poised to make paradigm-shifting discoveries. The impact of JWST on science will be immense and far-reaching. Beyond science, JWST resonates with our innate curiosity. It reminds us of the sheer scale, beauty, and complexity of the universe.